Aloha everybody, this is Gigi from Kauai Community College. In this video, we are talking about the quotient rule for taking derivatives. So suppose you have a function that is a quotient of two functions, meaning when you have a function that is composed of f of x divided by g of x, right? If you have a function that is a quotient of two functions and you are going to take the derivative of it, the question here is, what will be your derivative? Is it just the derivative of the numerator divided by the derivative of the denominator? And the answer is no. We already saw that in the product rule, right? The derivative of a product is not the product of the derivatives. So logically, we shouldn't expect the derivative of a quotient to be a quotient of the derivatives, because division is the inverse of multiplication. So the rules for multiplication doesn't work. That means the rule for division doesn't work out as we might think it is, right? So what is it exactly? We are just going to find it using the definition of derivative. So the definition said the limit as h go to 0 of f of x plus h divided by g of x plus h minus minus f of x divided by g of x, and then all over h. That is the definition of the derivative. Okay, now it's a complex fraction. So in order to clear a complex fraction, we will go ahead and multiply by 1. Okay, the question is, what is 1? How do you multiply by 1? Well, the 1 is something divided by itself. In this case, it would be the common denominator divided by the common denominator, which is g of x plus h multiplied by g of x. Now, when we do that, we need to distribute this red part here, that's 1, into each one of these terms. Okay, so visualize that. And when you distribute the 1 into the first term, g of x plus h will be divided out, and we will just have f of x plus h times g of x minus, when we distribute the red thing into each one of those, right, we would have, and then the denominator would also have that red thing there. Okay, so then we would have g of x is going to divide out g of x, and we would have in the second term f of x multiplied by g of x plus h. And on the denominator, you will have h multiplied by g multiplied by g of x plus h multiplied by g of x. So here, the one trick that you have seen when I was showing you the product rule was to go ahead and add 0 to the numerator. So here I am going to go ahead and add 0. And what is adding 0? I'm going to do this. Minus f of x, g of x. Well, I can't just go on minus f of x plus g of x. I'm going to go ahead and add f of x, g of x, right into it. So subtraction, addition of the same thing, that is 0. So I am really adding 0 to the numerator. Okay? And so what I'm going to do next is I am going to group them and factor. So this would be limit as h goes to 0 of, and I'm going to go ahead and split up the limit as h go to 0. The denominator is going to stay the same when I split the limit. So that would be h, g of x plus h times g of x. Okay, and then on the numerator, I am going to group this first term here with the third term here. What is in common in those two blue terms that I just highlighted? G of x, right? G of x. So g of x is in common. I'm going to factor out g of x. What is left inside? That would be f of x plus h minus f of x inside. Okay, and then the green two terms that have f of x in common. So I'm going to go ahead and factor out f of x. What is inside? G of x plus h. Then you would say, well, wait a minute, isn't that negative? Yeah, I'm going to go ahead and factor out not just f of x, but negative f of x. And if I'm going to put a negative right there, g of x then is positive. But then this right here is going to have to be minus g of x. Because negative g of x multiplied by a negative in the front, that's going to be positive. So that works out. Okay. Now I'm going to go ahead and change this h color to match the color on the numerator. And I'm going to change this h to the color that matches the color on the numerator. And you look at the screen, do you recognize something here? F of x plus h minus f of x all divided by h. That is a derivative of f when h is approaching 0. Right? When h is approaching 0, f of x plus h minus f of x all divided by h, that's the difference quotient. That is going to be the definition of the derivative of f. When h is approaching 0, g of x is still going to be g of x. Okay, all divided by g of x plus h is going to be approaching g of x. And then you have another g of x, which we can write g of x squared. Now, on the green, that would be minus. And when you look at this part right here, g of x plus h minus g of x all divided by h. And when h is approaching 0, that is a derivative of g multiplied by f of x. In the denominator, when h is approaching 0, g of x plus h is going to be approaching g of x multiplied by another g of x, which we now can write g of x squared. Let's clean this up a little bit. Both of them have g of x squared, which is a common denominator. So I can just go ahead and write all over g of x squared. And that is the derivative of a quotient. The derivative of the quotient is, and I would say, a derivative of the first multiplied by the second minus the derivative of the second times the first divided by the second square. And that is what we call the quotient rule. Okay, so let's go and practice that. Here is an example, and I'm going to go ahead and write the derivative again. The quotient rule said if you have a quotient and you are taking the derivative, I'm not going to write the of f of x because I think it's going to be simpler to look at. That would be g squared on the denominator. The numerator would be derivative of the first times the second minus the derivative of the second times the first. Okay, that's the quotient rule. And so you look at the quotient there. The numerator is 2x plus 1. The denominator is x squared minus 2. So then the derivative, when applying the quotient rule, you know the answer is going to have the denominator square. The numerator will be the derivative of the first, which would be 2, multiplied by the second, which would be x squared minus 1, minus the derivative of the second, which is 2x, multiplied by the first, which is 2x plus 1. And that is how you apply the quotient rule. What do you do with this now? You can simplify it if the instruction tell you to simplify. Otherwise, you can just leave it. But I think here we can simplify because I see x squared. So I know I'm gonna be able to simplify that. Distribute, I have x squared minus 2. Distribute, I have negative 4x squared minus 2x. So on the numerator, I will have x squared minus 1 squared on the denominator. On the numerator, I will have negative 3x squared minus 2x minus 2. And that is the answer, unless you can factor the numerator and reduce that with the denominator there. But I think as far as calculus go, this is good enough. All right, so that is the quotient rule. Maybe one more, something a little bit cleaner. For example, maybe we will talk about, well, how about the derivative of cotangent? Okay, so let's take the derivative of cotangent of x. What do we see? Cotangent of x is cosine of x over sine of x. So when you take the derivative of that, that is a quotient, right? That right there is the quotient. So the derivative of the quotient is, the denominator is going to be g squared. The numerator is going to be the first derivative times the second minus the second derivative times the first. So let's go ahead and apply that quotient rule. But we also know, let's remind ourselves, the derivative of cosine of x is negative sine x. And the derivative of sine x is cosine of x. Okay, so those are the information that we know. So in order to go ahead and find the derivative of cotangent x, we are going to go ahead and apply the quotient rule. The denominator is going to be sine x squared, or we would write sine square x. The numerator would be the derivative of cosine, which would be negative sine x multiplied by sine x, the denominator, minus the derivative of sine x is going to be cosine x multiplied by cosine x. So we have, when we clean that up, denominator is still going to be sine square x. The numerator has a negative and a negative. I'm going to go ahead and factor out a negative. The inside will be sine square x plus cosine square x. And we should recognize that that is 1. So this is negative 1 over sine square x. And that is negative cosecant square x. So then we would say the derivative of cotangent x is negative cosecant square x. Pretty cool. That's the quotient rule.